Hello everyone. In this video we're going to talk about section 6.4. Right, we're going to begin section 6.4, which is about logarithmic functions. Now logarithmic functions, as you'll see very soon, are very similar to exponential functions, okay, or they're related in some way, and so many of the facts that we talk about here will be similar to the facts that we talked about when we discussed exponential functions. So let's first define what a logarithmic function is. A logarithmic function with base a, where the base is greater than 0 and not equal to 1, is denoted by y equals log, L-O-G, base a of x, and is defined by the statement that y is equal to log base a of x if and only if x is equal to a to the y. And so we've got a lot to unpack here. And the first thing that you'll probably notice is that this if and only if statement is a strong definition statement, and it says the logarithm is only true if this relationship is true. And so on the right here, you'll see, let me increase my pencil size here. On the right, you'll see an exponential equation, or an exponential equation, and then on the left, you'll see what we're going to call the logarithmic equation. And so there's a very strong relation between the two. In fact, we'll see in just a second that they're inverses of each other. Okay, but we have a logarithm, which is always denoted by log. Like exponential expressions, it has a base, which is there, and then just the regular sort of input, which is x. Okay, and so with this definite relationship, we can do lots of things with it, okay? But we'll describe all kinds of stuff about logarithmic functions and equations and all that good stuff. So an important point, or something to keep in mind, is that the domain of the logarithmic function is x is greater than 0, okay? So by default, logarithms only exist when that input is greater than 0. So that's an important point that we'll see a little later on. If I try the log of 0, if I try log base anything, a of 0, that's going to be not a number. So that's not going to exist. And log base a of anything less than 0 is also not a number. We get an error there, okay? At least for this class. So with that in mind, let's try out our first skill, which is changing between exponential expressions or equations and logarithmic equations. This skill is going to be important because in order to solve logarithmic equations, we're going to have to change them into exponential equations. Exponential equations are a lot easier to work with than logarithmic ones. Okay? So let's start with the top here, and specifically I'll call this 1, 2, 3, and 4. So let's start with problem 1. We have 1.2 raised to the third power equals m. That's an exponential expression. We have a base raised to some exponent. We have a number raised to some exponent equals something. Okay? That's an exponential equation. And so I want to change that to be a logarithmic equation. And so if we remember, we had that log base a of x, y equals log base a of x, then, or we can equivalently write that as a raised to the y power is equal to x. Okay, if we go back here, we'll see that. If I have y equals log base a of x, if and only if x equals a to the y. So that's our relationship. So let's change this into a term with a logarithm in it. So the base of the exponent, the base of the exponential equation is 1.2. It becomes the base of the logarithm. So I have log base 1.2. Okay. Then, if we look at the exponential equation over here, whatever's on the other side of the equal sign, just the number, not what's involved in the exponent, what's involved in the exponential expression, but what's on the other side of the equal sign, that becomes the thing that you put, the input of the logarithm, and so that's m, or the thing that you put inside the parentheses, if we put parentheses around this. And then, on the other side is what we see is the exponent of the exponential expression, right? So a to the y, that's equal to 3. And so now I've changed from an exponential expression to a logarithmic, an exponential equation to a logarithmic equation, okay? And so I can do that. I can do the same thing with number 2, okay? So the base becomes the base. So now it's e, okay? And we learned what e was in the last section. It's just a number, 2.718 something, 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 okay? So log base e of whatever's on the other side of the exponential expression, or the other side of the equation that doesn't involve the exponential expression. Log base e of 9 is equal to the exponent, term b, okay? So that might be helpful to us, but often it's the case that we'll want to go backwards. So if we look at number 3 and I wanted to solve for a, it'd be awfully hard for me to try to think about that because it's really hard to think in terms of logarithms. I could, however, easily think in terms of exponents. That's much easier. We're much more familiar with that. And so let's change this from a logarithm to an exponential. And so to do that, the base of the logarithm becomes the base of the exponential. And so that's a. Whatever's on the other side of the logarithmic equation, which here is y, now becomes the exponent. So a to the 5th equals whatever's inside the logarithm, the input, which is 4. Okay, so now I have a to the 5th is equal to 4. And then in number 4, I can do the same thing. E's the base, so it becomes the base of the exponent. Whatever's on the other side of the logarithm equation becomes the exponent of the exponential side, equals whatever's inside of the log b. Okay? And so that's changing back and forth between exponents and logs. And so for the end of this video, here's a your turn. I have one exponential that I want you to change to a logarithm, and then the other side I have a logarithm, and I want you to change to the exponential form of the equation. Okay, so that's the end of this video, and I'll see you next.